The time for another motherboard has come. In this video, we're going to have a look at Gigabyte X570S Aorus Pro AX, which is a motherboard based on X570S chipset. The S stands for silent because it has no moving parts. The chipset heatsink is completely passive. In my opinion, it is one of the most interesting X570 boards on the market right now because it is well designed, it has some new features, and it's reasonably priced. Those of you who are looking to find a good match for the upcoming Ryzen 7 5800X 3D should definitely check it out. So without further ado, let's take a look at it. This is all the stuff which was part of the package. Motherboard, user's manual, 2 quick installation guides, a Wi-Fi antenna, CD with drivers and utilities. It is completely unnecessary, just something I will never use. The latest drivers and utilities always have to be downloaded from Gigabyte's website. You'll go there anyway for the latest version of BIOS. Then RGB LED strip extension cable, 4 SATA cables, Aorus special sticker, a G connector. I like this thing. It allows you to connect your front panel case wires more comfortably to the motherboard. 3 M.2 screws. I don't know why they are packed separately. I think they could all fit into one sack. And finally, Gigabyte X570S Aorus Pro motherboard. Let's check out the length of the cables. RGB LED strip extension cable is 54 centimeters long. Wi-Fi antenna cable is 79 centimeters long. And both pairs of SATA cables with straight connectors and 90-degree connectors are 50 centimeters long. So let's remove the plastic. And now let's start with motherboard's rear I/O. It has an integrated I/O shield, which is definitely a good thing, but at this price range it is expected. Here are 4 USB 2.0 Type A ports. They are mainly for peripherals like mouse, keyboard, or a wireless transmitter. These are 2 SMA connectors for the enclosed Wi-Fi antenna. They are connected to AMD Wi-Fi 6 802.11ax chip, so not Intel anymore, like the previous generation of X570 boards. If you have 6E compatible Wi-Fi router, you can achieve higher transfer speeds, up to 1.2 gigabits per second. The actual chip responsible is MediaTek MT7921K on an M.2 card, which also has Bluetooth 5.2 module. When we look at the block diagram, this card is connected by PCI Express to X570 chipset and therefore shares bandwidth with everything connected to it. Here is an HDMI 2.1 output supporting HDCP 2.3 and HDR, offering a maximum resolution of 4096 by 2160 at 60 Hz. You can use it if you want to use an APU, which is a CPU with integrated graphics. However, I have to warn you here, I don't recommend using them because all the APUs which were released till the release of this video disable PCIe 4.0 capability of the motherboard. This means that all PCIe slots and M.2 sockets for SSDs would run only in PCIe 3.0 mode, that means at half bandwidth. Or in other words, this would defeat the purpose of using an expensive motherboard with X570 chipset like this one. So if you want to use APUs, I'd get some cheaper B550 board instead. Then we have here 3 blue USB 3.2 Gen 1 Type A ports, which means that they all run at 5 gigabit speed. The second one, this one with BIOS written on the left, is the one that can be also used for inserting your flash drive with the BIOS in combination with QFlash plus button, which is here. This combination allows you to update the BIOS without CPU, GPU or RAM installed. It is for cases when you know that the pre-installed version of BIOS doesn't support your CPU. I have already done a video on this topic. You can find it on my channel. It was done for Gigabyte X570 Aorus Elite motherboard. All 4 red USB Type A ports are version 3.2 Gen 2, which means that they all run at 10 gigabit speed. So it is best to use them in combination with external SSDs or devices which require a lot of bandwidth. Here is something special. This is a USB Type-C 3.2 Gen 2 X2 port, which means that it runs at 20 gigabit speed. This is an upgrade compared to previous generation of X570 boards. They didn't have it. I'll surely test it in the nearby future. Above it is this 2.5 gigabit LAN port, which is using an Intel chip. 2.5 gigabit is the new default. If you want to be able to use it fully, you will need 2.5 gigabit switch. You can check out the video where I tested one recently. It was a really good one. You can find it on my channel. And last but not least are traditionally the audio ports. Here are 5 audio jacks and an optical digital output. They are connected to Realtek ALC 1220VB audio codec, which provides, I would say, decent audio quality. So let's now take a look at the motherboard from another angle. Here is a metal VRM heatsink, which has a large area for heat dissipation. It uses a heat pipe with an improved narrower gap design. It has plenty of fins, and I like it. It will do the job well. The height isn't too tall, so you can use large high-end air CPU coolers without touching it. The VRM under it is able to handle any 3000 series or 5000 series Ryzen CPUs, including Ryzen 9 5950X, so there's nothing limiting you when it comes to the choice of the CPUs. The height of both VRM heatsinks is 27mm from the PCB, so it doesn't interfere with coolers like Noctua NH-D15 or Zalman CNPS20X. The plastic cover at the back is 43mm tall from the PCB, so I think this is useful information. Noctua NH-D15 has a cutout in the heatsink with clearance of 64mm, and Zalman CNPS20X has 47mm clearance. Then you of course need to add the height of the installed Ryzen CPU, which is 4mm from the PCB. One more thing, when you're touching it, it is best to use gloves if you don't want to have fingerprints all over it, and also be careful not to scratch it when installing the CPU cooler. The AM4 socket supports 2nd gen, 3rd gen and 4th gen AMD Ryzen CPUs. The pre-installed version of BIOS already supports all of them. The only exception is new Ryzen 7 5800X 3D with extended cache, which will require a BIOS update because it was released after the release of this motherboard. So if you buy this motherboard and new Ryzen 5800X 3D, you will need to update the BIOS using QFlash Plus BIOS update function, or in other words, use CPU-less BIOS update. This applies to all motherboards from all vendors which were manufactured prior to its release. So it's not just something specific to this motherboard. I think this particular motherboard is a great fit for it. The PCIe bandwidth of the motherboard is dependent on the CPU installed, so using 2nd gen CPUs, or in other words Ryzen 2000 series, will disable its PCI Express 4.0 capability, so I wouldn't recommend using them the same way I warned you about using APUs which were released till the release of this video. You should be able to pick from these CPUs. If your budget allows it, go for Ryzen 5000 series, which have both higher IPC and clock speeds. The motherboard has 4 DIMM slots and supports dual channel memory setup. DDR4 memory modules are required, and you can use those with speeds up to 5400 MHz. However, price to performance sweet spot still remains to be 3600 MHz and CL16. Maximum overall supported memory capacity is 128 GB. That means 32 GB single DIMMs are the max. ECC memory modules are also supported, but always check QVL first to make sure the ones you chose are compatible. You should always check QVL on side of both the motherboard manufacturer and the memory manufacturer before buying any memory modules. This will save you from buying incompatible ones. If you're using only 2 memory modules in dual channel setup, you should place them in slots A2 and B2 according to this scheme on the motherboard, which says A2 and B2 first. You can't use dual channel memory setup with 1 or 3 memory modules. In fact, you should not use single channel at all because it has a drastic impact on the memory throughput of the whole system. You'd be crippling it. So use only combination of 2 or 4 memory modules. So let's take a look at the top side of the motherboard now. On the right, we can see a 4-pin PWM system fan header. Altogether, this motherboard has 8 of these PWM fan headers. I wish all motherboards had so many. All of them can be speed controlled according to the temperature from the temperature sensors, which are displayed in red on this scheme. The fan curve profile can be set from SmartFan 6 BIOS UI or in OS using a utility in App Center. Here are the CPU 12V 4-pin and 8-pin power connectors. The 8-pin can deliver over 380 watts, which is enough for any CPU you can put into this motherboard. However, if you can, you should connect both. I have tried using only one of them on Gigabyte X570S Aorus Master motherboard, and it worked. But for some unknown reason, the system behaved better at boot up when both were connected. So if I can, I always connect both. Here are another 2 fan headers. The gray one is called CPU fan header and the black one is CPU optional fan header. You can connect any fans to the optional fan header, not just the ones which are meant for the CPU. Next to them are these 2 RGB LED headers, one non-addressable and one addressable. Altogether, this motherboard has 5 RGB LED headers, 3 non-addressable and 2 addressable. You can control RGB LED lighting using RGB 2.0 software in OS. It also allows you to control LED lighting which is already installed on the motherboard. But if you don't like the RGB lighting, you can switch it off, of course. So let's take a look at the right side of the motherboard now. Here is the main ATX 24-pin power connector. Next to it are these 3 system fan headers. All of them are PWM. I really like that this motherboard has so many of them. Above them is this 2-pin header for the temperature sensor, which wasn't part of the package. However, I have never felt the need to use it even on motherboards that had it enclosed, so I don't find this to be a loss. Close to it is this USB 3.2 Gen 2 header, which is very important. You can connect your cable leading from the front panel case USB Type-C connector here. If the motherboard didn't have one, I wouldn't have bought it. It would have been a deal breaker for me. If you haven't bought a PC case yet, I'd recommend buying one which has USB 3.1 Gen 2 or USB 3.2 Gen 2 front USB-C connector. Remember that you want only the ones with Gen 2 port, not Gen 1. You will find the test of USB-C Gen 2 external SSD cases on my channel. They can be used for quick data transfers or a backup. Next to it is this 5-pin Thunderbolt header. You can use it in combination with PCIe expansion card, which can be put into this slot and which can be bought separately. The card itself requires 4 PCIe lanes, so in case you want to use it, you should definitely take it into consideration. When we zoom in a little closer to the PCB, we can see that there are 4 status LEDs here. They can help you with potential troubleshooting. When everything's fine, none of them should be lit while you are in the OS. I think this is a nice to have feature. Here are 6 SATA ports. The numbering is visible here on the PCB. As you can see, it starts with 0, not 1, from the top right hand corner. All of them support RAID 0, 1 and 10. And if you want to know more about RAID, you can watch my RAID special video, which can be found on my channel. One important thing which is worth mentioning here is that if you occupy the third M.2 slot, that means this one, M.2C, with an M.2 NVMe drive, it will disable last 2 SATA ports, 4 and 5, that means these 2. For most people, this isn't a big deal because they don't use so many SATA ports, but for some people this may matter, so that's why it needs to be mentioned. Using SATA SSDs starts to make more and more sense as their prices drop, so they can be a good replacement for traditional hard drives if you get a good deal for them, otherwise not. They are faster, run cool and consume very little energy in idle compared to hard drives and are reliable. Yet I wish there was some replacement for them in the future, because the M.2 NVMe SSDs run hot and require too many PCIe lanes, which is something most common consumer grade platforms and therefore motherboards don't have. So in most cases, people can use only 4 of them in one PC, 3 in the M.2 sockets and 1 potentially in the PCIe expansion card. And finally, the last port on this side of the motherboard is this bent USB 3.1 Gen 1 header, which can provide up to 2 USB ports. I like that it's bent because this corner is quite crowded, so it makes the cable management easier. So let's turn the motherboard and let's take a look at the bottom part. Here is a front panel header, which is for connecting the wires from the power switch, reset switch and K status LEDs. This is where you connect this G connector, which was part of the accessories of the motherboard. Make sure you match pluses and minuses correctly when connecting the wires to it. When I put it there now, there is really no resistance because no wires are connected, so I'll remove it. The arrow or a triangle on the plastic connector, which is at the end of the wire, signifies plus. Above it is a clear CMOS jumper. It allows you to clear and reset the system parameters to factory defaults. If you want to use it, you will need to turn off the computer and unplug the power cord. Then use either a jumper cap or a screwdriver or anything metal to show the pins for a few seconds. 5 is enough. If you use the jumper cap, remember to remove it after clearing the CMOS. Also, after you've reset the BIOS, you have to first boot up the system to BIOS and load the optimized defaults before you can start using it. Another way of resetting the BIOS is removing the battery for a minute, which is here. And before you do that, you also have to turn off the computer and unplug the power cord. Next to the battery is this second USB 3.2 Gen 1 header. It can provide up to 2 USB ports, but be careful when plugging the connector from the case into it. One of the positions for pins is filled, so there is only one correct orientation. Then we have here these 2 last system PWM fan headers. Above them is a second temperature sensor. Next to it are these 2 USB 2.0 headers. Each can provide up to 2 USB ports. Next to them is this TPM header. TPM stands for Trusted Platform Module, which is a microchip which provides hardware-based cybersecurity and authentication. If you want to use it, you must have one. This header has 11 pins and 1 blank. And next to it are these 2 RGB LED headers, 1 non-addressable and 1 addressable. Here is an undocumented connector labeled LED demo. You won't find it in the manual. It features a micro JST 125 2-pin connector. it's for an external power input to illuminate the LED capabilities of the motherboard without having to power it. It is probably for the testing of the RGB before it leaves the factory. If you power it, the RGB on the motherboard cycles through all the colors, and it requires 5 volts. And the last header on this side of the motherboard is this HD audio header. So let's take a look at the main connectivity now. When we look at the motherboard from this point of view, we can see that it's beautifully and efficiently designed. No space is being wasted. It's really a pleasure to look at. This is how these X570 boards should have been designed from the very beginning. So let's start from the top. Close to the VRM heatsink is this hidden CPU LED header. This is for coolers which offer LED lighting. I like that it's there because it's out of the way for CPU coolers with large evaporators. And now let's talk about the PCIe lanes. All AM4 motherboards based on X570 chipset have 24 PCIe 4.0 lanes available for connecting devices to it. The distribution of these PCIe lanes on this motherboard is following. 16 of them is shared between the first 2 PCIe X16 slots, which are reinforced by metal. When only the first one is occupied, it will use all 16 lanes for itself and none for the second one. So this is the best one to use for your GPU. If both of these slots are occupied, each of them will run with 8 PCIe lanes assigned. That means each will use half, unless you manually redistribute them differently using bifurcation setting in the BIOS. The second one is electrically connected only by 8 PCIe lanes, so even if you leave the first one empty, this one will always run at X8 speed max. So that's for the first 16 PCIe 4.0 lanes. Now another 4 lanes are exclusively dedicated for the first M.2 socket, which is also directly connected to the CPU, so it is the best one to use for your M.2 NVMe SSD with OS and applications installed on it. And the last 4 PCIe lanes are connected from the CPU to the X570 chipset, which is hidden under this heatsink, and which enables sharing this bandwidth between the third PCIe X16 slot, which is electrically capable of running only using 4 lanes, not 16. Then with all SATA ports, which are here, then with both M.2 sockets, which are under these 2 heatsinks, and with both LAN adapters and many USB ports. You can see it best on the block diagram, which was included in the manual, so you can pause the video and study it at your own speed. I'm giving Gigabyte a thumbs up for that, because it wasn't available in previous manuals for X570 boards. Now, you might be thinking that so many devices sharing only 4 PCIe lanes could be a problem, but because all of these devices aren't usually used at once while running at their full speed, in most cases they aren't a bottleneck. However, for some special use cases which require more bandwidth, this could be a limiting factor, and in that case you should opt for a Threadripper or a Threadripper Pro, which have 64 or 128 PCIe lanes. So let's now take a look at those beautiful M.2 heatsinks. I will uninstall them one by one. So the first one is out of its socket. We can see that it has a notch here, which can be inserted into the M.2 socket on the side. At the bottom it has this pre-applied thermal pad. You'll just have to remove this sticker before using it. This heatsink is really heavy. It weighs 44 grams, so the cooling will be excellent. The second heatsink is really large. It weighs enormous 74 grams. It was probably designed to cool 2 M.2 NVMe SSDs at once, as it is in case of Gigabyte X570S Aorus Master motherboard, but here it cools just one M.2 drive. The third M.2 heatsink weighs 38 grams, which is also generous. It will be able to cool any M.2 NVMe SSD without any problems. All three M.2 sockets, M.2A, M.2B and M.2C, support M.2 NVMe SSDs and M.2 SATA SSDs of sizes 2242, 2280 and 22110. 22 is the width of the drives and the second number is its length, both is in millimeters. What is worth reminding here is that if you occupy the third M.2 socket, M.2C, it will disable the last two SATA ports, 4 and 5. What I really like here is that you can remove each M.2 drive individually without removing the heatsink from the other ones. And the last thing we haven't talked about is X570 chipset, which is hidden under this heatsink, which is really large and which will cool it very well. I like this solution, and this is what should have been used from the very beginning with previous generation of X570 boards. So let's now turn the motherboard to the other side and let's see what's there. My inbuilt weighting mechanism is telling me that the motherboard weighs 1424 grams, which makes it the heaviest X570 board I have used so far. When I was carrying it from the shop, I felt something was different. I like that Gigabyte decided not to cheap out on cooling. The only thing we can talk about here is this AM4 backplate, which is made of metal and looks really sturdy. So that's all. This was a long video, so I'll be brief. I hope you found here what you're looking for, and if not, feel free to use the discussion below the video. I'll do my best to answer. So that's it. Thank you for watching and see you in the next one.